more like the big white ball from The Prisoner. It's funny, but you're not quite sure why it's there.
Now I have to go and alert all the flat earthers who thinks that mass attracts mass, that's not really the case. Now I got to tell everybody that they really meant matter attracts matter. I'm sure they don't know about
violating coronavirus restrictions.
You understand what I'm saying? I got to alert all of these people.
I got you. Yeah, you guys have confused mass.
Everybody,
man. I gotta tell them all. Stop crying, man.
Are you going to help me do this or what?
No, you misunderstood. So that's your own problem. Sort it.
Slick, that's your fault.
They
said mass. They said mass. You were supposed to know. They said they meant. You were supposed to know they meant matter. That's your fault. Slick.
I know it's my fault. That's what I'm saying. I got to go now explain this to people.
You know.
Hey Jeremy, have you ever seen any matter without mass?
Or mass without matter for that meeting.
What's up? What'd you say? I missed it. I got a lot of shit clanking around in here.
Well, because small amounts of matter don't necessarily attract any amount of other matter. It takes a massive amount of matter to start attracting other matter. Which is why
massive. Oh, okay. So is mass part of if? You put mass and if together and...
I wouldn't say it like that, man.
Yeah,
Slick, what he means is you need a large amount of mass. Xana, come on, man. Don't cut.
How would you explain?
I think what he meant to say is you need large amounts of matter to actually see the attraction happen. Because even you have an attraction on the sun, but because you're so small compared to the sun, we don't see you pull the sun. But
in Cavendish, was there? But in the Cavendish experiment, was there large amounts of matter in the Cavendish experiment?
No, small amount. I think he meant to say you need a large amount for it to become visible with the naked eye. With Cavendish, there was an attraction, but it was very small.
Yeah, I mean, like enough to make something orbit something.
Okay.
Something the size of Earth.
Yeah.
If you actually want to see
so we can throw out the Cavendish experiment now too.
No one's throwing it out.
No,
the Cavendish experiment proves mass attracts mass. It's just the attraction.
Was it a large enough amount?
It's a large enough. As long as you have something with mass, there will be an attraction to something else that has. You see it with your eyes. That's why with the Cavendish experiment, you need instrumentation that is so sensitive.
Oh, okay. So it's not the size of the mass, then. It's just you need the instrumentation.
Yeah. I can have two photons, right? They both got mass, and they'll attract each other, because they're so small.
What?
No.
Hold it now.
Did I say photons? Not photons. I mean protons.
I've never even observed protons doing anything.
I apologize. I meant to say protons, not photons.
All right, good on you.
I
apologize.
Nate, why did you say that the protons attract? Because of their what?
They have mass.
Aha.
That doesn't happen, man.
Matter has mass.
Happen.
It doesn't happen. That's never been observed.
What do you mean, protons?
Yes.
So what is the nucleus made out of, if not protons combined with...
You think that they're attracted by gravity?
Hold on, wait. You're getting into the strong...
I said they have mass. So they are attracted to each other through the strong nuclear force.
So what does that do with gravity?
Well, they said that mass don't attract mass, Nate.
An ionized hydrogen atom is a proton, man.
Yeah,
Nate, there's a new...
As long as it has a positive charge, it's a proton. But who says mass doesn't attract mass?
Yes, that's what I'm saying. I don't know if you're Nate. I don't know if you're aware of the new rule, but no longer does mass attract mass. Matter attracts matter now. This has just got established today.
Are you guys telling me all those?
Is there a difference?
Well, that's what I'm saying. They established that mass doesn't attract mass. Only matter attracts matter.
No, mass.
But is there a difference between those two statements?
Mass is made up of matter.
According to them, yes, there is a difference between those two statements.
Mass has matter. It's a big deal.
Are you telling me all those years
I think you got that backwards? Matter has mass.
Matter has mass.
Is my mic on?
Mass has matter.
Check. Yo.
Yep, your mic is on.
Yeah, Jeremy, we can hear you, man.
We're just ignoring you. Sorry.
What the fuck?
That's bad wording, saying mass has matter.
It's been covered. Thank you. Jeremy, please.
No, I have to call Danik out. He always adds in the bad semantics.
Shut up,
Okay, go ahead. Call me
Fuck
out.
you.
So,
I won't shut up.
So mass
Somebody
doesn't
shut
have
him
matter?
up, please.
All those
No,
years,
Kurt. If Danik's going to confuse people
if
by
I have
adding
a
extra bad
property,
words,
matter
I'm going
is
to call him
stuff.
I
out.
know.
No.
I want to hear it. I'm more than happy to entertain this question. If I have a kilogram, is it
Danik,
not made up
it
of
had
matter?
already been addressed, man.
I
Why
know,
do you
but he was correcting me, and I want to make sure that I'm staying.
Someone just wants to fuck up the voice chat more.
Mass is the property, matter is the stuff.
Right. But it also matter. But hold on, mass is also made up of matter.
The property is not made up of
here.
stuff. The
No,
stuff has
mass is a property of matter. Danik, what are you talking about?
Mass is a property of matter.
Yes.
Yes.
Is mass not made up of matter?
No, it's not a thing to be made of anything.
Is blue made of blueberries? No, blueberries are blue.
Danik, you're ridiculous. This
If I
is
have
why.
if I have a kilogram
You're as
mass,
bad as a flat earther.
if I have 1 kilogram mass, is it not
Here we
made
go
of matter?
again.
Yeah, it tells us how much matter is in your thing, right?
Right.
Mass
So it's
is
made
how
of
we
matter.
measure matter.
So then I'm right. So you have a kilogram mass, and it's made up of matter. It's telling you how much matter is in it.
Explain it to us again, Danik.
Correctly
You have a
proportional to the
kilogram. You have
accumulation
a
of
kilogram mass. 1 kilogram mass. It is made up of matter, is it not?
I think he was joking.
I think we got a new show here. Not Groundhog Day, but Groundhog Hour.
Yeah, it is definitely.
Hey, we want you in the house, Sonic.
Thank you.
It's cold out there, campers.
Remember.
So in other words, Nate, there's a new rule in town. Long story short, Nate, there's a new rule in town.
So what it's
It's not a new rule. It's
Mass,
but it's the
mass
same
no
thing.
longer attracts mass. Matter attracts matter now. Mass, no, they changed it.
Both are correct. Both are correct.
Is that the 43rd time you said that, Slick? You want to go for 46?
It's the same thing, Slick.
I know but I'm telling you, it's not the same thing. They changed it today.
Yeah, no, and you said
So
that
one
like
person
48
told you
times
that,
now.
and it doesn't mean it's worth repeating. So
Well, I've been saying mass doesn't attract mass for about a couple years now, and
you've been wrong for a couple years.
Oh, I
now.
wasn't in the middle of a
Yeah,
sentence, guys. My bad.
All right, Jeremy, you wanted to say something earlier before Dawn kept derailing you. Could you use this opportunity to say what you wanted to say?
I did just now, and they wildly interrupted me. Did you hear it?
That was it?
Wildly.
That's all you wanted to say.
I want to say I've been saying for years that mass doesn't attract mass, and everyone was yelling at me. You're wrong. It does. We got proof. Cavendish.
No, that's what you
Yeah,
were trying
you
to
are
say
wrong.
when Dawn kept interrupting.
Yeah.
Really, Jeremy?
Well, I apologize, Dawn. I would have rather heard what you had to say than what Jeremy was going to derp out.
I had to call Danik out because he's using bad wording. You should get him.
But the point is,
Go
Danik
ahead,
had
Don.
already
Correct
been
me.
called out on it.
Seriously, Don, I want to be corrected. I want to be I want to be true and correct.
Well, then use the correct wording and stop arguing with flat earthers.
Well, no, I just said that mass is made up of matter.
It's not, though, is it? Because if you look it up,
tell me why it's
mass
not.
is a property and a measurement of matter.
Okay, it's measurement of matter. What kind of
You
measurement?
know
is
this,
it?
so I don't know why you're even
Well, I know, but I
arguing
just said
it.
that I had a kilo. Well, I'm trying to use the logic that you're trying to help me with here. So if I have a 1 kilogram mass, is it not made up of matter?
Yeah,
let's try this.
Most of the
Let's try
time,
this.
but we don't
Matter-
say that.
But it
Yeah,
is.
matter has attributes like color, and charge, and mass. So if something has mass, it's an attribute of something. It's just a metric. It's something that's describing what it is. You can say how much mass it has or what color it is. Now, so if you see the color green, it's not like you can't say the other things. Oh, that's green. That means that's matter. You know what I mean? It's you don't describe the attribute and then say you have the substance.
Yeah,
you know what I mean? So there's no point arguing
If
that.
you see something green, would you say it's made of green?
No,
Then why do you insist on doing that with
because the color could be the outside of it. Could be made of green. If green could be made of green things.
Oh my God, Sonic.
Purple drink.
You're gonna die on this hill,
You're
aren't you?
supposed to be the smart one.
I'm seriously. It's more of a philosophical question, but I just said, hey, like I have a kilogram mass. Is it made up of matter?
This is bad philosophy. It is.
Well, no. If I have a kilogram mass, is it not made up of matter?
This is philosophical.
Whatever.
Saying you have a kilogram mass is a label for the thing. It's not saying you have a bunch of property.
No, I didn't say I had a bunch of property. I said I had a kilogram mass.
Not like property like land, a bunch of attribute.
Well, yeah, if I have a kilogram mass, that means I have two things. I have a kilogram worth of matter, and I have...
It doesn't mean you have an attribute in your hand. It means
can I finish?
have a bunch of mass with a particular attribute.
An attribute, a property of mass, is inertia. So it has inertia. It also is made up of matter. No?
No. But it has inertia because it has mass.
Right, and is mass made from...
Inertia is a property of matter, not mass.
Oh, so inertia is not a property of mass?
Property of matter.
Okay.
Did you not watch Bill Nye when you were a kid?
That's someone I don't really look up to. He has less of a degree.
That was the intro of the show. Inertia is a property of matter.
He has a mechanical engineering degree, and I have something a little higher than he has. So I don't look
if I was going to take it further, are you saying all the dark energy is all matter that we haven't found?
We're not talking about dark energy.
Yeah, but this is all the mass. If he says all mass is matter, then we've lost 90% or 99% of the matter, right?
All
haven't found it yet.
All mass is made up of matter. What did you say?
That's what you said.
No, I didn't say that. I didn't mention dark energy.
You said mass is matter, always.
I said mass is made up of matter.
Yeah, okay.
Made for matter.
So you're just saying sometimes.
Dark energy isn't dark matter.
No, I want to be. If I'm, I find this very interesting.
Did he just say that mass? Did he just say that? Did he say that mass is made up of matter?
Yes.
Yeah. Don't listen to him, Slick. He's doing a Slick.
Brenda, please
doing a
tell
Slick
me.
James, making word games.
Brenda, I'm listening to you, and I want to be. I want to be helped here. If I have a misunderstanding, I want to be straightened out here because it's kind of always said that. But
Brenda's looking out for you, man.
So no, go ahead. So if I have a kilogram mass, is it not made up of matter? Does it not contain? Does this kilogram mass? Does it not contain matter?
When you say
Brenda's looking out for you, man.
What are you saying?
What about dark matter? Where's all the matter?
Dark. You're going to talk about dark. I'll ask you a specific question. Now you're talking about dark matter. We didn't really understand that, do we?
If I follow your reasoning, all this mass that they're missing, you're saying it's all matter. It's not just mass from some other way.
So you got to define antimatter then first, or dark matter. What is dark matter?
Well, I thought you were the expert.
Is dark matter matter?
I thought you're the expert on this.
No, I'm
just saying, is all the mass in the universe all matter?
The only thing I've said is that I have a kilogram mass and it's made up of matter, is it not? And you're talking about dark matter and other things. So help me understand. Go ahead.
I'm just wondering, do you think all mass is made of matter always?
All mass is made of matter. Yes, I would say that.
Okay. Yeah, I would say yes as well because we haven't seen matter.
Yeah, that's what I was kind of asking. Have we seen any mass? Have we seen any mass without matter?
We haven't seen non-mass.
We've seen. Mass. We've seen the effects. We've seen the effects of mass without mass being there. That's different, right? But that doesn't mean that mass doesn't have matter.
Hey, Zanik, you gotta agree though. Brenda's being pretty deep, man.
No, I like Brenda. I want to hear Brenda's objection. I don't have a problem with. I'm not arguing him. I'm just asking, right? You understand the difference?
You mean her? Come on, dude. Use the right pronouns.
Brenda, I'm sorry. So just clear up my thinking then. If I'm confusing mass and matter in this particular context, if I have a kilogram mass, is matter not made of? Can anybody argue that a kilogram mass does not contain matter? First of all,
no, I wouldn't argue.
Yeah, it can be made of antimatter.
Really?
How?
Oh, you don't know
that. Please show me how that can be possible.
Going down that path.
It's a simple question. If I have a kilogram mass, is it not made from matter?
I think you're phrasing the question wrong, Zanik, and I think that's the main issue. It's a semantic issue. You cannot have a kilogram mass. You have an object that weighs that has a kilogram of mass, right? You have an object, right?
Okay, I have an object that is a kilogram. That is a unit measure of mass.
Yes.
Okay, so that mass, does it contain matter?
No, you have the object, right?
Okay.
And that object is matter, and it has a mass.
What is the mass? You said it has a mass, so what is the mass? A kilogram?
Yeah, Zanuck, you're right, dude.
You're conflating the label of the object with the property.
I'm asking. I'm not complaining anything. I'm just saying, what is it?
But you're saying when I have a kilogram mass, you have an object that is called a kilogram mass because the matter it is made of has the collective property of 1 kilogram of matter.
Hang on.
Yes.
I'm now looking. It says
I like
energy.
that. I like that. It's slacker. I like that. It's good.
Dark energy is mass energy. So are you saying all of that is?
Why are we back on the dark energy?
No, keep the dark energy out of here. Dark energy is a label for things.
So you're not
like
sure
that.
about all mass being matter?
No,
we don't know.
cares.
We don't know if that does not fit the mass definition.
It's mass energy. I just looked it up.
Mass can be energy. Yes.
The density of dark energy is very low, much better than the ordinary matter of dark matter within galaxies. However, it dominates the mass energy of the universe.
Yes. So is it
But you're
mass?
saying it's not mass?
It's not mass. It's antimatter.
Oh, okay. Antimatter.
Remember, they're filling in the void. They see things happening that say the mass should be here and it's not. So they're calling, and they can't see it, so they call it antimatter. They call it.
You saw
dark matter and
Dark matter is not antimatter. Those are two different things.
Oh, sorry, misspoke. You're right. Sorry, dark matter. Yeah. Dark energy.
Dark matter is also not antimatter.
I mean, most
Neither
of
of those things.
I haven't brought up dark matter. Brenda's bringing up the dark matter. I'm not bringing it up.
Most of what we know about dark matter is how it affects things around it.
Right.
Yeah.
So all we know is the effect. We don't know what it is.
Exactly.
We see it. We see its effects.
But antimatter, as far as I know, is pretty well characterized, right? We even synthesized a few. I don't know.
Does antimatter have?
Did they synthesize one atom of antimatter? I think 1 hydrogen atom antimatter was done.
Does antimatter have antimass?
Yeah,
no, it has mass.
I don't know. I assume so.
A positron has mass. It's just like an electron, but with a positive charge, not with a negative.
Yeah.
Positron. Yeah.
And there
that
is
true,
radiation
actually.
which gives off positron radiation.
Yeah, those things do have mass for sure.
Okay, to form positron.
They
So that
measure
is
those
well
shit.
characterized, but dark matter is not so well understood.
So a kilogram. Let's get back to the kilogram. The kilogram mass I possess. Does it not contain matter?
Can I ask you a slightly different question? What's the thing you're trying to understand? Well, I think what we have is a semantic difference, and we have no difference in any kind of substance. So I would always ask, what are you trying to understand, and what are you trying to understand that I don't understand, and why do we not understand each other? What do you think is?
Well, I don't know if we do. I mean, there's been people throwing a lot of things out here as far as what mass is, and units of measure. I'm saying that mass is made up of any amount of matter, and that it has a property called inertia, and that's pretty much all I've really ever said.
Okay, so what do we know now that we didn't know before? And what can we do with that?
You know that
knowledge?
Slick will not accept our definitions, no matter what they are.
Well, wait. If we're talking about Slick, we know he's not going to accept anything, so it's irrelevant, right? That's a given, is it not?
Yeah, that's a given.
Well, it's all about acceptance. I mean, it's all about acceptance, right?
Slick, I wasn't talking to you right now. I know,
but I was talking to you. I know, but I was talking to you.
Yeah, I know, and I'm not interested.
That's too bad. Thanks for stopping in.
Yeah, I know. So anyway, Zanuck. Yeah, I know. Maybe it's because at heart, dispositionally, I'm a pragmatist, and if something can't make a difference in my life, I really don't pursue it all that deeply. Mm-hmm. And maybe that's the difference between you and me dispositionally, and maybe you have some kind of deeper interest in just truth, as truth's sake. And maybe that's, where you and everybody else here differs, but maybe not. And so, but in order to get to that, we'd have to understand what you're looking for.
Well, do we ever have equations that are based on matter? Do we ever say that F equals matter times acceleration? So they use the word mass. Why do you think they use that term mass in Newton's equation?
Because all the equations are based off properties.
Right. Exactly. So
the math works, and it makes it easy.
So if we have
to
a
do
kilogram
the
mass, and someone says, "What is mass?" and someone says, "Oh, it's any amount of matter." Semantically, I think you can continue to dig deeper, but why do you need to? I mean, wouldn't that suffice?
Well, that's what I'm saying. That's what I'm
asking.
The
formula really means force equals matter times acceleration. That's what the thing really means, right?
What does matter have? Now, there we go again, back in circles again. Does matter have mass?
No, what I'm just saying is that the equation must be wrong, because it must mean that F equals matter times acceleration.
The equation isn't about the stuff; it's about the properties of the stuff.
Right, exactly. And we're talking about the properties. So, what is inertia?
A property.
And what define inertia? What are the units?
Resistance to change in movement.
Right.
Just But we all had these courses, right? We know this stuff. We all passed college physics. Well, not all of us, but I'm guessing you have. And so we understand these terms in any way we need to do to get to understand anything about the world we need to understand.
Right.
And so my question is, what more do you need to understand about it in order to
I don't
solve any problem?
I think
in other words, you understand it enough to be blue-pilled. Right? Yeah, you understand it enough to be blue-pilled.
We're having a different conversation.
Exactly. No. See, but here's if you let Slick drive the conversation and define the terms, you will go forever down this rabbit hole, and you just waste your time.
It's not
the problem with Slick is not a question of science.
I totally agree with that. I totally agree with that, because that's what I tried to stop Scott from doing, because Scott was literally explaining the same thing over and over, and to ignore everything that Scott said and says, "So what did you say, me mass? It's all the drag mass." It's just like, literally pointless explaining to him if he's going to keep reverting back to the same fucking bullshit.
Oh, I was ignoring Scott. I wasn't ignoring Scott. I was trying to
ignored everything he said and reasserted what you said.
I didn't ignore anything. I heard everything. I heard everything that Scott said.
Why the fuck would you revert back to the original statement? If I ask a question like, "What time is it?" Someone tells me the time, and I go, "What time is it?" It's fucking irrelevant, isn't it? You ask someone the time, they tell you the time, then you then digest what they say. It's simple. You don't reassert the time, reassert the question after they've explained it.
Scott was loud and clear. I heard him perfectly.
He basically, can I summarize real quick? He said that basically mass is a measure of matter. And the unit of measure is the kilogram. And I totally agree with that. I think everyone here would.
Yeah. It's a measurement. That we understand this. It's a measurement.
Hold on. Did you hear what I said?
Yes, it's a measurement.
The measurement of the amount of mass, amount of matter. And that measurement is the units of measurement are the kilogram, for example. There's others, but that's one.
It's a measurement. We heard you. Yeah, I heard you. It's a measurement. I heard you.
No. It's a measurement of the amount. But the amount is just out there. It's like, I have height. What does that mean? What is the height? Well, you got to measure it to get the height, right? We know that if you get the amount of distance from one point to another, that distance will be its height from the ground to upward, vertical. That will be its height. Now, what is it? Well, we can use it. We can measure it in terms of the inch or the yard or meter.
Why are you bringing height into this? Was there height in your definition?
It's also a measurement.
I know, but why are you bringing height into that definition?
An analogy. It seems like you don't like.
We don't need an analogy. Listen, an analogy is not necessary. It said it's a measurement, loud and clear.
What does a measurement mean? What does the word measurement mean?
We were almost out of it, and we need to get drawn back into this. So Xanax got to help make sure we get all the way back into this.
I just still didn't, I asked a simple question, and there was a little bit of discussion between Slacker and me about, mass being made up of matter, and there was a little bit of a, semantical discussion there. But Slick is going off the deep end here, talking about you guys don't know. You said it's a measurement, so how can a measurement have any properties?
We're not going to get anywhere.
Right off with
we're talking about it anymore.
Measurements don't have properties.
Them right down there, man.
Right? No, that's not what we're saying at all.
Is that? Can I ask you another question? One more question, personal question.
Sure.
And I say that as an inhabitant of somewhere on this scale. Have you ever been tested to figure out if you're on the autistic scale anywhere?
What scale?
The autism scale.
No, none.
Most engineers are, right? I'm kind of on it myself.
No, I'm definitely.
So
I
have
have ADD for sure. I mean, I'm definitely very, focused.
You sound more like a schizophrenic. You sound more like a schizophrenic scale.
Yeah, right.
Yeah, sure, whatever.
He's right.
Yeah,
Engineers
exactly.
are.
You're right.
We're a little
I'm a
quirky. I'm a
You
little
sound like you're on a schizophrenic spectrum.
Yeah, that you don't even know what that word means, so don't use it. And but you know what? You could be right though, because I'm a little bit country. I'm a little bit rock and roll. Yeah, I'm a little schizo.
Yeah, so that song goes.
I don't mean a little. I don't mean that literally, by the way. Although I am literally.
It just seems like you're very strongly invested in communicating an idea to someone who doesn't seem to want to hear it, and you seem to get very, very frustrated when they won't hear it.
I think it's a challenge, right? It's a challenge. Like, how can I not? I understand this. How can I not? How can I not explain it to somebody that doesn't know anything about it? The challenge is if I'm
that's a good question, right? Yeah.
If I'm hold on, let me finish. If I'm unsuccessful, I'm pissed at myself that I failed. So I want to continue to try to figure out how to explain it.
Well, you must like being pissed off at yourself. I mean, the amount of times you go on Naked Office show and he just shouts at you for an hour. Like,
Dude,
why would you do that?
The man said that mass is a measurement. Now, he said it with his own
mouth.
Oh,
God.
I'm making a separate point there. Like, if it frustrates you to do this, you shouldn't do it, should you?
Slick is very high on
if this upsets you, I'll stop saying it.
No, it upsets me because I'm failing at it and helping you understand the basic term here.
Okay, is mass a measurement?
Fair. I hear you on that one, man. I'm with you actually on that one completely.
Zanuck, is mass a measurement? Zanuck, is mass a measurement?
Let's Slacker.
Dude, just answer the question. I want you to answer it. Is mass a measurement? I'm not talking to schizo.
Yes, and measurement's done in kilos.
So it is a measurement.
It can be. It's got to be.
Dude,
mass is
it a measurement or not?
Mass has properties of inertia. Mass has property of the amount of matter it contains. Mass has a lot of characteristics and properties. Which one do you want to talk about?
I want to know if mass. All I want to know, Zanuck. All I do.
That words have multiple meanings. Listen,
I only want to know if mass is a measurement.
I have a hard time understanding that words have multiple.
I heard you. No,
you didn't. The entire time I was saying that, you were talking.
You said about the flat earthers. I heard you. Now I'm asking you.
What did I say? What did I say about the flat earthers? What did I say?
I heard you.
What did I say then? Repeat it.
Dude, is mass a measurement or not? I'm not repeating. I said no.
So you didn't hear it. So you didn't
I said I'm not repeating it.
Well, I'm not.
No, I won't repeat it.
You didn't hear it because you were
talking. No, I won't repeat it.
You're repeating.
Now, is mass a measurement? Now, you said mass is a measurement. Are you going to give me a straight answer or not?
I would agree that it's been talked about today that mass is a measurement. Measure how much matter is in a.
Thank you. You don't have to keep rambling on. No further questions.
How do you measure mass?
You measure its resistance to acceleration.
Resistance to acceleration. Oh, get into that, Slick.
Height.
What is matter?
That doesn't mean that the object is made of height. Fuck's sake.
I know you want height to save you here, but it can't.
What do you mean save us?
If we're going to be semantical about it, I would say that mass is a property and we measure properties.
Dude, he already gave me my answer. Mass is a measurement. There's no need to
I'm
try
giving you
to
a
clean it
slightly
up.
different answer.
No, I'm not dealing with that. I'm going with Zanuck's.
Mass has properties.
Mass is the measurement.
Properties, for sure.
It's a measurement.
What kind of measurement?
Period. Mass is a measurement.
What kind of measurement?
It's a measurement.
You say you understand it. You say you understand what we're saying. So what do we mean?
Okay, so let me ask you this.
What do we mean?
You just said a little while ago that mass is a measurement. Now, did you say that or did I mishear you?
Explain what we mean by that.
I'm trying to find out if I misheard you. Did you say mass was a measurement or did I mishear you?
This could not be a better conversation had than this.
I think we can clear this up. Finish up, Mr. Kerr, because I was going to say I think this is easy to see that you might want to listen to Slacker, because I think Zanuck is a good friend of mine, but I think he believes that Don is.
Well, like I said, Zanuck, you said that mass was a.
Because that's Don.
Who's Don? I know I was talking.
You were calling Don Brenda.
No, I mentioned two names. Slacker and Don. It's only two names I mentioned so far, besides you.
Yep, you're on that spectrum, dude. You're high on it too.
What do you mean?
Yeah.
The schizo. He's talking about the schizo spectrum.
No, autism.
It's all right.
Your ability to follow what other people are saying is mind-bogglingly absent.
Zanuck, it's okay. I got 2 kids on the spectrum. You're good.
Every goddamn person in here knew what Kosho was saying except for you. Not trying to be harsh, Zanuck, but you got to wake up and realize, dude.
That what? Go ahead. Wake up and realize what? Go ahead. I'm listening.
You want me to repeat it?
Yeah, repeat it. Go ahead.
No.
Okay.
Zanuck, I'm on your side. You said mass is a measurement. Hey, I'm with you. I'm with you all the way, big time.
He's talking about something else.
And even after all this, he still thinks he was talking to Slacker and Brenda.
I saw Slacker's light shine up, and I was responding back to him a couple times.
Yep, you did. And who was the other person that you kept calling Brenda?
Well, I meant to say Dawn. Sorry, I don't. We don't have pictures here. We just have lights that light up, and the voices are sometimes hard to recognize.
Let's not mention it at all and move on.
That was Dawn. That was
You
Dawn.
actually thought Dawn was Brenda?
That was Dawn. No, I didn't say Brenda. I said maybe I did. If I did, I was mistaken. Sorry.
Multiple times.
Well, then sorry. Hey, I misspoke. You never misspoke.
When he was saying Brenda, I was wondering who the hell he was talking about.
I meant Dawn. Sorry.
Wow, he called you Brenda.
Dawn, we both have posh feminine voices.
Dawn, I'm sorry if I called you Brenda. Okay, all right, get over it.
Zanuck gets so fired up.
I'm over it.
Okay, not you, everyone else. Jeez.
You could tell you got ADD or ADHD or something.
ADD?
I was
maybe a little.
I'm wondering where the fuck is Brenda? I don't see her on the panel.
Oh, would you stop it?
No, I'm just saying it was funny because I heard you saying Brenda,
Kelly,
but I didn't see Brenda.
Just responding fast as I can.
I'm not picking on you. I
said
just heard the name
measurement.
Brenda.
Yes, it's a measurement of how much matters in an object and given in the units of kilograms, for example.
I appreciate you. See, I appreciate you for saying that. Other people wish you would shut the fuck up, but I appreciate you.
That in no way implies measurement attracts measurement, you fool.
Oh, listen, come on, man.
That's a good point. So Slick, that's a good point he's made there. It nowhere implies that measurement attracts measurement, even though so you can't use that kind of false logic. If this equals this and that equals that, then these two things are equal. They mean the same thing. That's not how it works.
The semantics that you just found.
Yeah, really. Zanuck, keep talking.
This is a breakthrough.
Zanuck, you should just keep talking.
Well, no, you said measurement. Just because something's a measurement and measurement is this, then that equals that. No, that's not how it works.
I hear you. Keep talking.
Yeah. I would say the mass is not a measurement. Mass is a property, and we measure properties. The only way we have access to properties is by measuring them.
Yeah, keep talking.
Yeah, a property could be how much of something, right?
It's all about the precision of the language there.
It could be how much of something, its resistance to acceleration, among many other things that mass has properties of.
Like I said, keep talking.
Mass has properties.
Listen, I've got all the information that I need, so I'm cool.
Mass is the property? So what is inertia?
Mass is a property of matter.
Is inertia not a property of mass?
Inertia is a property of matter.
Is it not a property of mass?
It's a property of matter.
Is it yes or no question?
Properties don't have other properties.
Okay, well, you're saying that, you're asserting it, but now we've come to the crux. We've come to the fork in the road here. Is inertia a property of mass? Yes or no?
I would say no. Inertia is a property of matter.
I think personally, I think you're wrong, but that's okay. We can disagree.
How does a measurement have? How does a measurement have a property?
I challenge you to find any physicist that would back you up with that claim.
How would a measurement have a property? Mass is a measurement. You're saying
because it's another property.
You're falling in the same hole that Slick fell into.
I'm not in no hole. What the fuck you talking about? I'm not in no hole.
Measurement equals measurement. You said that.
I'm enjoying the hell out of this. There's no hole.
You said measurement can't equal measurement, or measurement can't.
No, I said how does a measurement have a property?
This is why we call you dumb sometimes, Jeremy, because you fall into what Slick.
I'm not saying. No one's saying a measurement has a property.
Ain't nobody fell into anything. I'm enjoying it, so there's nothing fell.
I bet you are.
I'm having a ball here.
I know you're the stupid kind of person that would do that.
I know exactly.
You've been up like 36 hours or something.
This is very enjoyable.
Mass is used interchangeably for matter, yes, but in the more specific definition,
in precise language, yeah, it often is.
Lemon, does mass have?
It's not.
Lemon, is inertia a property of mass?
Interchangeably for matter. What was that?
Inertia is a property of mass.
Is that true?
Is
Lemon?
it a property of matter? Does matter have mass? Yes.
Basically, it's saying it's interacting.
Let me blow your mind here real quick. Say it again. Matter. Okay, so mass has a property called inertia, and does matter have inertia? Yes.
Hold on.
Matter,
you just said
matter be
now a property has a property.
Matter mass?
You're gonna get lost in this. I think.
This sounds like that Who's On First with the Three Stooges.
No. This is just being accurate, right?
Yes, Janice, Zanik, let's be accurate. Does a helium-4 that is made of 4 hydrogen atoms has less or more?
Does the helium fall when made up of hydrogen atoms? What was that question?
Yeah.
How does helium made up of hydrogen?
It's fused.
Hydrogen is made up of helium?
No. Helium is made of hydrogen.
It's made from, but it's not the same. Once they fuse, they become helium. They're not.
Yes,
hydrogen is not two helium atoms.
Is there less matter? Is there less matter in helium than in hydrogen?
Is there less matter than? No, hydrogen has less matter than helium.
No,
it doesn't.
Hold
on, it doesn't. You're saying hydrogen?
One helium. Does one helium atom has less matter than 4 hydrogen atoms?
No, they're the same matter.
So why does it weigh less?
Because you just gave me a situation where you have 4 times something that is 1/4 the mass and asking why it has less mass. I mean, that's a circular question and makes no sense.
No, it's not.
It is, because we all know that 4
1 plus
4
1
hydrogen
plus 1
atoms will weigh the same, will have the same molecular mass as 1 or 2. What you said? 4 hydrogens, and I forget how many you said. 4 hydrogens and 1 helium.
1 helium. Yes.
Who's on first?
Well, he's making a point here. So go ahead. I'll let you go ahead. Make the point.
The point is that the helium has less mass than the 4 hydrogen.
Of course.
Why does it has less matter? What matter does it has?
Because it has more protons and more electrons.
No, it is the same. As the same amount of quarks.
What's the molar mass of helium versus what's the molar mass of hydrogen? Go ahead.
Never mind molar mass.
No, that's the molar mass. No, let's talk about the molar mass. What's the molar mass of helium versus hydrogen?
I have no idea.
Well, go look it up. You should know this if you're asking this kind of question.
No, I'm not asking a molar mass. I'm asking
that's the same question.
Of the atomic mass. No.
Yes.
The atomic mass.
You don't think the atomic mass has anything to do with the molar mass?
Probably is.
You don't think they do? Come on.
All right, wait.
I said probably is.
Of mass. A mole is a number of whatever it is you're counting the number of. Like if it's carbon atoms, it's a specific number of carbon atoms. If it's hydrogen atoms, it's a specific number.
Yeah, same number. And we have a different mass for that number.
Not a total amount. It's not
it is.
Number of
it is. You have the same number of particles, but if they have more mass, it has more. If you have more mass, it will have more mass.
Oh, that's
beautiful. Yes, but we're comparing 4 to 1.
Right. So 4
seriously, if it has more mass, it will have more mass. You said, can you take that down?
Well, no, I mean, I don't understand what the question is.
It's a mole is like 60 quintillion units.
I'll tell you what the question is. The question is, why does a helium atom weigh less or has less mass than 4 hydrogen atoms?
Can you repeat that question, Jake?
And the answer is it has less energy.
That's
We
what?
have no idea what the fucking question was.
Yeah, we can't understand your question. I still don't get it.
You don't get
He
it.
said, why does the mass of a helium atom have less mass than 4 hydrogen?
Does it?
Of course it does. You got energy from it. Has less mass.
This ideology would demand
the molar mass of helium should be more than 4 times or less than 4 times, whatever your relationship was, than of hydrogen. Is that true?
You're comparing now, really not what I was asking. I was asking,
asking for the weight
atoms against 1. 4 against 1, not 1 to 1.
No, I didn't say 1 to 1. I said 4 to 1. Okay, even if you added them together, sure.
So you take four atoms of hydrogen. They have certain mass. You take one atom of helium. It has less mass than the 4.
My question is, does it?
What?
Do you mean more mass than the 4?
Less. I said less.
It would have to logically if you're fitting more of it in the same amount of space. If you're able to fit more of something in the same amount of space and they have the same fundamental unit in weight and mass, by logical extension, the thing would have to be way less for you to be able to fit more of the same.
expialidocious.
So you need to carry the implications of your ideology to their logical conclusion.
Keep it simple,
it would
please.
weigh less
My brain
by
is
that
frying up.
logic.
Keep it simple, Lemon.
What does the volume have to do with it, Lemon?
If you're fitting more stuff at the same volume and everything's the same, then what's different? The weight, the mass. That's the only way you can fit more in there.
Volume. Volume clarifies the density, man.
No. What is hydrogen made of?
What Curve said is very true. The more mass within a smaller volume leads to a more dense object.
Volume's not
That's exactly what
in the
neutron
weight
stars are heavier.
or the mole or the molar mass of it. Density is not a factor. The volume is not a factor. It doesn't come into that limit.
Yeah,
density is amount of stuff per unit volume. This would reduce to the same thing if your ideology is consistent.
Well, think about it.
It's about the amount of it, not the volume of it.
Which would translate to weight, unless there's something else affecting the weight.
Which is not about the volume of it.
Curve, this is reducing to lighter mass that would be expected.
However distributed it is, you're referring to a number of the particles or whatever, atoms, whatever you're dealing with.
Yes.
The matter.
And if the particles are different size, you would be able to fit more of them in a smaller space.
You're erroneously introducing that into this limit.
If the particles were a smaller size and therefore a smaller weight, you would be able to fit more of them in the same space versus a bigger weight.
That doesn't matter.
Why are we even talking about this? This ideology is not even consistent. This ideology is not even consistent because you're implying that they're made of the same unit of stuff, yet when you fit more of the same unit of stuff in the same space, you're saying that it's not having an implication on the weight? That's absurd.
Just stop.
What?
Stop.
What?
He's out of his fucking mind.
Just keep it simple, Lemon. Just keep it simple. That's all you
I can't keep it this simple, Brummy. I'm sorry. People are just... I'm sorry. People just aren't thinking. They're just not thinking.
I can't keep it simple, Brummy. People need to step up and think. You add way too much words onto something that's unnecessary. You need to just stop talking about all different sorts of stuff. keep it simple.
There's nothing wrong with the way that I'm saying stuff.
It is though. It is because no one understands
That's
what
all I'm
you're
going
on
to say.
Nobody
understands it, Lemon.
See and complete his flyby.
So,
what was your point? Sorry. What is your point exactly? That
you'd expect something to have smaller weight like hydrogen if you're fitting more of the units of the stuff, whatever it is, in the same amount of space. As something else where you're fitting less of it in the same amount of space.
Then it becomes more dense. If you put more of the same stuff within a more confined space, it becomes denser. It's like saying if a room only holds 100 boxes and you put 200 boxes in there, then it's going to be more dense.
Yeah. And you can fit a bunch of marbles in there, like millions of marbles, and the marbles are pretty light.
Oh, okay, I hear what you're saying. A different sort of molecule which will add more weight, which isn't the same thing. You see what you mean? So you could add, say, the boxes represent oxygen, and then you add these little marbles which represent, I don't know, fucking hydrogen, and you cram more hydrogen and oxygen into the same room. It'll become more dense, and it'll be made up of two different matters, but it'll still be a denser matter overall.
Yeah. And like Chaiki was saying, you'd expect the marble to be smaller if you're fitting more of it in the same space, where this big hydrogen box, was in the same space and you could only fit 8 boxes of hydrogen. You can fit millions of pebbles. By extension, logically, you'd expect the helium pebbles or whatever, hydrogen pebbles, to be pretty light.
I don't know.
Not what I said.
I'm not too sure I follow that. Do you make sense of that curve, what he's trying to say? The pebbles basically aren't going to be the same weight as the boxes.
You wouldn't expect it to be.
Lemon is, if I'm correct, you would expect the helium boxes to weigh more because they're bigger than the little marbles, right?
Yeah,
that is correct. Yes.
That's what you would expect, but what would turn out in actuality is that the marbles would weigh more.
They'd actually be heavier. The marbles will be heavier.
Yeah,
the individual marble would be lighter than the individual.
It's like look at this. Look, this is evident. The sun itself it weighs, let's say, 100 tons, even though it's the wrong answer. Let's say it weighs 100 tons, but a neutron star, when a sun collapses in on itself, becomes extremely more dense and a lot more heavier, but it's a lot more smaller. So even though it's smaller, it still weighs a lot more than the sun today. So actually, smaller objects tend to be heavier than bigger objects. Is that the answer, right?
No. So Lemon, what I would say is, so we got the helium and we got the marbles, right? And the helium is more dense. So gravity is trying to pull the helium, the balloon full of helium and the balloon full of marbles down as well. But gravity is not trying to pull these down through a vacuum. It's trying to pull it down through a medium, whether it's a medium of liquid or a medium of gas, right?
Or ether.
All right, even a medium of ether, right? So we got to assume ether is made of matter. So gravity is trying to pull matter down through matter. But because gravity cannot pull you through something else, gravity needs to make a choice. Am I going to pull the ether down, the medium, or am I going to pull or helium? So based on what's more dense, gravity pulls one down and the buoyancy force pulls the other up.
But at that point, gravity is not a universal force that acts on all things universally. It's selective, which is a bit of a problem.
How is it selective? Because it's still pulling something down. Yeah, but I told you, gravity has to make a choice as to what it's going to pull down. The medium or the object in the medium.
But at that point, shouldn't it pull everything equally? If it's a universal force?
How so? Because
it's gravity is supposed to be a universal force.
What do you mean? What do you mean by universal force? Pull two things down at the same time. Universal just means if the conditions are the same, it doesn't matter where you are, this phenomena is going to appear the same. Whether you're this side of the universe or the other side, you're going to use the same formula to calculate gravity if the conditions are the same. Now, gravity is trying to pull two things down into the same space. It can only pull one thing down into that area of space. The medium, which is displaced, or the object displacing the medium. You know,
the
it's
only
like me
thing that I've
trying
ever seen that has an organizing force is sound and frequency. Because you can put salt on a sound plate and it will organize into different shapes based off the frequency alone. So why aren't we talking about sound and frequency as an organizing force as opposed to gravity? If gravity has to do this level of selection, why don't we go to something else that's real selective, like, you know, form, sound, and frequency, which
All right,
organizes
well,
stuff
then
into a
you
bunch of
got to
different
come up.
shapes?
You got to come up with the theory as to how sound keeps us on the ground, and test that theory. You know, you can hypothesize and, you know, what if and maybes and if buts and whys all you want, but until you can back it, no one's going to take you seriously, man. You know, and you say the most, Lemon. I mean, you ain't no idiot, but everything you say clearly comes from your head. It's your own ideas, your own opinion.
I've shown you guys incoherent magnetism over and over again. That's gravity that you can turn on. That's demonstrable. Why are we even talking about gravity when you can turn on gravity, gravimetric effects right now with electromagnetism? Why hasn't gravity been absorbed into electromagnetism? It doesn't even make sense. You can demonstrate gravimetric effects right now. Right now, a general attractive force.
Magnetism, it's a force that counteracts the pull of the gravitational pull of the Earth. So it's just because we have rockets, for example, we don't say rockets. Oh, because we have rockets, there's no such thing as gravity. Whatever energy you use to counteract gravity doesn't mean like the electromagnetic force that you're saying. That's just something that's propelling. You know, that's the force that's acting down on us. Your body is constantly under the magnetic pull. If you do a handstand, the blood will rush from your head to the bottom of your head. Sorry, if you do a handstand, all the blood should run to your head. Why is that? Why do you want to do a handstand? All the blood goes to my head. Why is that? Because of what? Buoyancy and density.
Medium sets the rules.
What? Because of buoyancy and density. When I do a handstand at the wall and the blood goes to my head, it's buoyancy and density. What's that got to do with it's in a closed system? My blood is within a closed system, so why does more blood go to my head when I do a handstand? Answer the question.
There's still ether passing into your body. Just
ether.
Like
what are you talking about, man? Seriously, like, shut the fuck up, man. I'm done. I can't talk.
Well, I mean, you stop thinking because it got difficult for you to imagine it. I understand, but please don't stop thinking.
What got to do with handstand, man?
I'm taking to talk to you like you can actually understand what I'm talking about,
what
okay?
Do you mean ether? Like, what does that got to do with it? What the fuck does
respect
ether
and the
mean?
courtesy of talking to you as if you can think about what I say in a logical, intellectual way, okay?
I'm asking you, right, why does the blood go to my head when I do a handstand? And you talk about ether?
Body.
Why does that matter? Why is that a response? Why does the blood go to your head and do a handstand? Don't talk about ether.
There's another explanation for that. You do know that your veins and arteries have different numbers and different types of valves. The arteries have valves that two-way. The blood can go both ways.
So when you hold your hand up in the air, when you hold your hand up,
so your blood is going to tend to get caught up in your body.
Okay, so when you hold your hand up in the air, why does the blood rush out your arm when you hold it up in the air for too long? Why does your arm get tired? Why does your arm get tired?
Pressure with your veins or your heart. You know, with
you're in denial. You're in denial about the fact that your body's under constant. Your body is under constant pull towards the earth.
I'm trying to talk to you, Brummy, but you're switching up the conditions. Your arm's not even as big as your body. You're talking about a totally different volume of blood.
You switched to the condition about arteries, so I said to you, what about the
your arteries and your veins have different numbers.
When you lift your arm in the air, there's no arteries
in your arteries.
You're not inverting the arteries in your arm. You're not inverting the arteries in your arm. You're not inverting the arteries.
Your body in a different way, Brummy.
So I said, if you put your arm in the air,
when you do that handstand, you're going to feel a different amount of pressure from the one-way course of the blood in your body through these veins that have one-way valves that close.
So, Lemon Bird, when I say you put your arm in the air, right, you keep your hand the same way it's inverted as usual. You keep your arm in the air, your arm will get tired, the blood in your arm will rush down out your arm, and your arm will start to get tingly because there's gravity pulling you, because your heart is working harder to push the blood up your arm, right? Now you're holding it directly in the air, yeah, it will get tired, and there's no inversion of any veins in your hand. So why does your arm get tired? And you're saying ether, and there's nothing to do with your veins because your veins are still up the way they're supposed to be. It's nothing to do with your arteries. Now, what is your excuse now? What is your excuse now?
You have arteries and veins in your arm, though, and your arm is the rest of your body.
So it doesn't. It only seems to work right. It's a bit weird that these arteries only seem to work when you do a handstand. And now I say when you put your hands in the air, which is the opposite direction of a handstand, you then talk about your opposite. Well, which one? It can't be arteries now because when you do a handstand, your hands are facing towards the ground, and when you put your hand in the air, it's completely the opposite way, and yet you still get these different effects. So you explain to me.
It's not quite the same.
You're trying your body
and below your head.
The conversation's over. The conversation's over because you're just showing your intellectual dishonesty.
Above the rest of your body.
You're showing your intellectual dishonesty. You're not just being honest about the conversation.
Okay, you're trying to do this. This is great. You're trying to have an intellectual conversation. This is great. But you need to match the conditions. When you're doing a handstand, all of the blood is going down. All of it.
Yeah, of course it is.
When you're standing up, you have a totally different condition. Your head's here, your body's here, your trunk is here. Most of the blood
your blood is still going down. When you stand up,
when you place your hand, most of the blood is still going toward the trunk of your body. So you're not even matching the conditions.
It's always going down, no matter what position you hold.
You can't even think about it because it's not making similar conditions, Brummy.
Listen, you lie on your left-hand side, your blood's going to the ground. You lie on the right-hand side, your blood's going to the ground. You stand up, the blood goes to your feet. You do a handstand, the blood goes to your head. The blood always goes to the ground, regardless of what position your body's in.
That's not quite true, Brummy. You have muscles and arteries and veins, like I said, with different valves and different functions, too. It's a bit more complicated than that.
It's not. It's simple. There's a gravitational pull down on you constantly, and you can feel it. And you're in denial. And you're making up bullshit like ether and veins. You're in denial. You're not an honest person. It's simple. You're in denial of yourself. You are in denial with your own biology, your own self. Simple as that.
But when you're standing up, the blood goes up to your neck, but your neck doesn't get tired.
I don't experience that. Sorry. I don't experience that. Lemon Bird, you're in denial. Instead of just saying, you know what, this makes sense. You know what, I do tend to stand up, blood goes to my feet. I do handstand.
It doesn't make sense because helium rises while everything else is pulled down. Gravity's disproved right there.
Yeah. But let's forget about that because we're talking about the blood in your body that you can personally feel. And when you're lying down and you're standing up, if you was an honest person, you'd say, you know what, that does make sense because it does happen.
At all. Helium rises in a medium, not in a vacuum. The reason helium rises in a medium is because gravity is pulling something else down, the medium itself.
There's still a medium there that would provide the rules, called ether.
But how come we don't see the ether have an impact in a vacuum? In a vacuum, the balloon does not rise. Why is that?
There's still a medium making the rules. The group of interactions with the medium decides if it rises, sinks, or falls.
So what are the rules of the ether? How come ether works different from other mediums all of a sudden?
It seems to be similar rules. If you're, less dense than the medium, you fall. Less dense, you rise. If you're more dense, you fall.
So is the ether more dense?
It would be the least dense thing in this scenario. Yes, the least dense thing would be the ether, the background, the thing that makes up space.
So if the ether is less dense, then things should not float in the ether, right? So
the ether is less dense, so it would have to interact equally with the ether.
Yeah, if the ether is less dense, things should sink in the ether. How come
everything would sink in the ether? Yeah.
Yeah, but how come we don't see things sink or fall? We don't see stars sink. Since they're bigger than Earth, we don't see them sinking or fall below Earth. We don't see things fall out of the sky. If
the sun and stars are set within the firmament according to the Bible, they're not in the ether. They'd be in the firmament, and those waters above the firmament.
Lovely.
About the vacuum in the lab, it wouldn't be the same as the waters above in space. They'd be two different things. If you're talking about the background of space in the vacuum
for the firmament. Okay.
About the firmament, yes, I've given you the evidence over and over again with the parhelion, the sun dogs, the elves and sprites, the electrical activity that looks like it's hitting a barrier at a certain altitude. The Schumann resonance, it makes it look like the Earth's a vibrating hollow cavity. This stuff points to some sort of firmamental covering. And the stars look like blobs of light bobbing and undulating in water. When you get away from NASA's GI, that is.
Not really, man. Stars just flicker. They don't look like they're underwater. But it's cool, Lemon. I mean, you clearly have your ideas set in stone. I don't know what evidence you've seen that, verifies these ideas for you. But hopefully one day you wake up to the truth, man.
One try I learned today is that mass does not attract mass. And whenever you see mass attracts mass, that's just a dumbed down burden for the dumb.
But Slick, I mean, why can't mass attracting mass and matter attracting matter be the same thing?
That's the measurement, so measurements can't.
Sorry, man, you're breaking up. Because what?
Is a measurement. I don't know if I'm still up or not. Mass is a measurement, and measurements can't attract. Out. Uh-oh. Think about.
Yo, Slick, sorry, man. I dropped out. I didn't hear a word you said.